So like half wave rectifier, we can perform full wave rectifier. So let us first know what is full wave rectifier here. A full wave rectifier circuit produces an output voltage or current which is purely DC or has some specified DC component. Full wave rectifier has some fundamental advantage over their half wave rectifier counterparts. Half wave rectifier we have used only one diode. In full wave rectifier we have to use two diodes, both the diodes. In the diagram we require two diodes. So current is going to flow from diode 1 and diode 2. Full wave rectifier consisting of these two diodes connected to a single load resistance RL, with each diode taking it in turn to supply current to the load. The resultant output waveform. So the voltage across this half wave rectifier is given by these two formula. DC voltage is equal to 2 into V max divided by pi, that is equal to 0.637 V max, that is equal to 0.9 V RMS. I am going to make the connections with the help of the circuit diagram for full wave rectifier. So in full wave rectifier we have to select these two diodes. So let us make the connection across these two diodes, the AC power supply of 12 volt for both the diodes. To this diagram I am going to complete the connections for AC power supply voltmeter, AC voltmeter, including these two diodes. So first I am going to connect positive terminal of the AC voltmeter and the negative terminal of the AC voltmeter. Okay. Then we have to connect here this common terminal to, we have to select these two diodes. So I have connected this to the one diode, and another diode we have to connect using the patch cord. So next we have to make common connection to these two diodes, and this must be connected to the voltmeter. So here is the common connection, and we have to connect it to the voltmeter, AC voltmeter. Okay, we have made the connection, and one more terminal we have to connect 0 volt to the negative terminal of the voltmeter. So I have connected a complete circuit connection for AC voltmeter. So next we have to move on to DC voltmeter and DC ammeter. So take the patch cord here, connect positive terminal to the positive terminal of this voltmeter and negative terminal to the negative terminal of the voltmeter, and a positive terminal of ammeter to the positive terminal of the milliammeter. Okay, and one more we have to connect negative terminal to the negative terminal of ammeter. This is the complete connection for full wave rectifier. So here we have two voltmeters, one is AC and another one is DC, and ammeter, that is DC current we can measure, and load resistance, two switches are there, and the AC power supply of 12 volt. Here we have selected two diodes, and here is the inductor of 200 millihenry and capacitor of 1000 microfarad across both the switches. is the load resistance of 50 ohm to 10k ohm. So let us switch on the device. So you can observe the deflection in AC and DC voltmeter as well as DC ammeter. So the voltage across the DC AC voltmeter is near to the 24 volt, because we have selected here both the power supply of 12 volt. So here the AC voltmeter reads 24 volt, and which is fixed. Here DC voltage we can observe it is around 7 volt, 7.5 volt, and here the AC DC ammeter reading, the current reading is about near to between 150 to 200 milliampere. So for the 50 ohm load resistance, we are observing the AC DC voltage values and DC current value. So let us switch on the switch 1, press the switch 1 and observe the results here. So there is a deflection in the DC voltmeter. It has increased by increased to 10 volt, and the current also has risen nearly 200 milliampere. So then you can press the switch S2 and observe the results here. So here the still voltage is same 10 volt and current also. When we switch on, press the switch S2. Okay, but the AC voltage must be fixed, that is near to 24 volt. So next, if we vary the load resistance, whatever the changes will happen we can observe here. For minimum load resistance 50, the DC voltage is 10 ohm and current is 200 milliampere. If I increase by 100, voltage is going to increase, current is going to decrease. So voltage has reached near to 12 volt, the current is between 100 to 150, nearly 125 milliampere. Because according to Ohm's law, voltage is directly proportional to resistance, but current is inversely proportional to the applied resistance. So voltage is rising in the DC voltmeter, current is decreasing. So as I am increasing, this is 500 ohm, 1k ohm. So when I apply 10k ohm, current is minimum, it reaches to 0. The voltage is how much? 17 volt. So there is a fluctuation in AC voltmeter, but it is near to 24 volt. So this is how you can perform full wave rectifier. Tabular column for full wave rectifier: input AC voltage you should note down, output voltage. So when you switch on the switch S1, measure the output voltage, and when you switch on the S2, you should note down the output voltage.